This recording is for Pre-Algebra Chapter 10, Lessons 1 through 2, and we're going to be talking about the area of parallelograms, triangles, and trapezoids. So, many of you guys have seen these formulas before, but these are formulas that work on their specific shape without leaving anything else. So if it's a parallelogram and you need to find the area, you can use the area of a parallelogram. Triangle will work on triangles, and trapezoids work on trapezoids. Okay, and hopefully remember the definitions of them from the Chapter 9 material on naming and classifying these figures. Okay, so the area of a figure is the number of square units encloses. So if I draw a box and I count the number of squares inside of it, I'm going to get the area of square units, right? They're units and they're square, so it's how many square units fit inside. So in this case, 18 square units. But I can use what I know about the length and the height and multiply them, or at least the length and the height and the base is what we're going to be using, height and base. And if I multiply them together, I'm going to get the area. So I can do it by math or I can do it by counting. The thing about counting, though, is it doesn't always work if you have shapes that cut boxes in halves or quarters or thirds or fourths or whatever. So it's easier to have a formula so that you can just plug it in and do the math, and it will give you the answer instead of counting boxes. So for this green rectangle, I have a base of 2 and a height of 6, and so I'm doing base times height, which is the area of a rectangle. Base times height, well, that's 2 times 6, and that's 12. Now notice how I have inches, 2 inches times 6 inches. Well, I can actually split that up into 2 times 6 times inch, because I'm actually multiplying by inches here, which means that when I have an inch times an inch, well, it's the same as like 2 times 2, I can write it as a square, like 2 squared is 4. Well, in this case, inch times inch is inch squared. So the area is actually 12 inches squared. And those are the units you're going to be using for area. It's going to be the unit squared. So if it's meters squared, or yards squared, or feet squared, or any type of length measurement. When I'm counting with the boxes, and I don't know what the size of the boxes are, I would say units squared, because I don't know how big my unit is or what my unit is. But if I know what my unit is, like inches, then I say inches squared. Alright, so an example of converting. You may actually have to convert some units before you can do stuff. So you may need to convert units, and so for this particular one, I have a rectangle that is 24 inches by 4 feet. And there's 2 ways you can do it. You can convert the inches into feet or the feet into inches. So the first one, I'm going to go ahead and convert feet into inches, and I'm going to get my inches, or you can convert, well, let me slow this down. Perfectly paused, huh? So again, you can turn feet into inches, or you can convert inches into feet, which is probably the more practical one. 12 inches or 24 inches is the same as 2 feet, because you divide 24 by 12 or 24 by 12 and you get 2, and then 2 feet times 4 feet is 8 feet squared. All right, so a rectangle is a special kind of parallelogram, and the formula for the area of a parallelogram follows the formula for the area of a rectangle. But instead of length and height, which we had been using previously, we still use height and base. But the height is also the altitude, and the altitude makes a right angle with the base. And it's very important you pay attention to that, because sometimes the book is going to confuse you. An altitude is a line segment perpendicular to the line containing a base of the figure and drawn from the side opposite the base. So if you find the base and then draw a perpendicular line, you're going to get the height, also known as the altitude. And so here is where it can get confusing. See how I have 3 measurements on that purple parallelogram down there? Well, 6 is not, if 6 is the base, the right degree I have is not the actual height. Yes. So it matters. So the height in this case is the 7 centimeter measurement, and the base is the 8 centimeter measurement, because things would change if I accidentally used the 6 instead of the 7. So make sure you are able to identify the height. All right? So beware of the tricky problems. All right, so let's go ahead and find the area of the parallelogram. Well, 8 inches is the height, and I know it's also the altitude because it forms a right angle with the base. The base is 3.5 inches, and I'm going to go ahead and multiply them to figure out the area of my parallelogram. Now, we can also do this with a very funky figure, something that looks like a rectangle but has maybe a square cut out of it. So I'm going to find the area of the larger rectangle and then subtract the area of the smaller square to find the area of the entire object. So the area of the bigger rectangle is 150 centimeters squared, and that's because it's 15 times 10. And then I need to find the area of the smaller one, that's the cutout area right there, and I'm going to subtract them. So by finding the total area and then the area that isn't there and subtract them, I'm going to get the final area of the figure. So if the smaller square is 25 centimeters squared and I subtract them, I'm going to get 150 minus 25, which is 125 inches squared. Or it's not inches, Miss DH, I was using centimeters. Wait to get my units correct. There we go. Alrighty. So let's go ahead and go on to the next slide. Triangles. The area for a triangle is 1/2 base the height. So we're still using the base and height from the previous slides, and we're taking half. And that's because you can always take two triangles and double them to get a full-on rectangle. But we end up not wanting the whole, we want the half. Okay? So again, that's why we use 1/2 base times height, because a triangle is really like half of a square or half of a rectangle. And so if we only want half of it, we have to have it. So that's why it's area equals 1/2 base times height. All right, so let's go ahead and figure out the area of a triangle. We have this triangle which is 5 meters by 2 meters by 5.4 meters. And we want to visualize this kind of as a rectangle. So I'm going to go ahead and do this rectangle part. So there's the full-on rectangle, and if you would look at the rectangle, the dimensions of the rectangle would be 5 by 2, where 2 is the base and 5 is the height. But I only want half of it to get the triangle, so it's going to be 1/2 the base times the height. Well, the cool thing about halves is that if you ever have a 2 that you're multiplying by that half, they cancel into 1 and they just cancel out. So I crossed out the 1/2 and the 2, and that left me with the answer of 5 meters squared. And we can also use these same principles to do irregular figures. The same way that we did the last one where we subtracted them to get rid of an empty space, now we can add two figure spaces together to get a total. So if I have a square that is 4 yards by 4 yards and a triangle that has a base of 4 and a height of 4, I can add those two areas together to get the area of this total kind of weird house on its side looking figure. So the square is 4 by 4, which gives me an area of 16 yards square. The triangle is a 4 by 4, but there's also a half going on because it's a triangle. And half of 4 is 2. 2 times 4 is 8, and we have 8 yards square. So now we have the area of the triangle and the area of a square. By adding them together, we're going to get the area of everything, which is 16 yards squared plus 8 yards squared, which is 24 yards squared. Alrighty, last thing we need to talk about is trapezoids. A trapezoid is basically two triangles of different shapes that make up the trapezoids, alright? Which leads us to the formula that we basically have two triangles put together where the only thing that's different is the base of the triangles. The base of one triangle and the base of the other triangle are different, but the height is the same. So that leads us to our formula. The area of a trapezoid is equal to 1/2 the height times the quantity B1, or the base 1, plus B2. Alright, so let's go ahead and use this in action. So here's my trapezoid, and it has a base of 2 feet, a second base of 4.5 feet, and a height of 4 feet. So let's go ahead and plug this information into the formula. Well, the formula was, the formula was area equals 1/2 height times B1 plus B2. Well, let's go ahead and replace that. The A is still the area, 1/2 stays the same, the height is 4, base 1 is 2, and base 2 is 4.5, and now we're just going to use the order of operations. So I'm going to do things in parentheses first and combine the stuff together so that those things go together. So 4.5 plus 2 is 6.5, and then I'm going to take care of the 1/2 and the 4, and 1/2 of 4 is 2. 2 times 6.5 is 13 feet. So the area of this trapezoid is 13 feet squared. Pretty cool, huh? All right, so make sure you memorize those formulas because they're going to be super handy. All right, guys, I'm recording this the day before I go on spring break, so I hope everybody has a good spring break. If you're not watching this before spring break, I apologize for the temptation. Bye.